As promised, here is a video of the 1.3 notes. Like I said, I really don't think that this is super difficult. I think you guys will catch on to this really quick. So a couple of vocabulary words to start. You need to know about arc length, which is the distance along the arc of the circle. So pretty self-explanatory. You want the actual length of the arc of the circle. We're also going to talk about sector, and specifically sector area. And sectors are just a chunk of circle in between two radius. And we'll two radii, and we'll kind of talk about that a little bit. But here's your circle, here's a radius, here's a radius. This is a sector. Okay. So hopefully that's pretty self-explanatory too. So finding the length of the arc of a circle, you need to realize that a circle has a circumference measurement already. We know how to find the circumference of a circle. The circumference of a circle is 2 pi r, or diameter times pi, because 2 times r is diameter. So either way, it kind of depends on what it gives you, which one's super helpful, right? So for this circle, we know the radius is 12, and we know that the angle of the arc that we're looking at is pi fourths. So what I'm going to want to do here is I'm going to say, okay, well then this is 12, this is 12, this is pi fourths, and I'm trying to find this arc length. I'm trying to find out how long it is. And so, back in the olden days, how we had to measure these arcs was we had to like cut rope or something that was flexible, that we could lay it out flat and measure it, but we could also bend it across that arc and see how much of the rope it took up. And that was really difficult. And so that's why we have these things. We have these formulas to do this, because it was really a pain to do that. So what we know is that this is pi fourths radians. We know that the whole circle is 2 pi radians, right? So if we have the pi fourths radians, what we're essentially doing is we are converting the whole circle into just a chunk of the circle. And so we do it like a conversion. If you guys have ever taken chemistry, this comes up a lot, that we use conversions this way. So what we do is we multiply by the entire circumference of the circle. Now I got the circumference of the circle by doing 2 pi r. So of course that's 12 times 2 times pi, 2 pi r, right? So 24 pi is the length or the circumference of the entire circle, and we know that 2 pi is also the entire circle. Okay, 2 pi radians is the entire circle. So what this does is it puts a radians on top over here and one down here so that they will cancel. And then this is a length measurement, right? Now, these pi's are also going to cancel here, which is very convenient. So really what we have now is we have pi fourths times by 12 lengths, which of course is just 3 pi. So the answer to how long that arc is 3 pi. And if you think about like the circumference being from here all the way around to here, if that's 24 pi, and we just want this little tiny 45 degree, pi fourths degree part of it, it makes sense that that's going to be 3 pi, because if we took the whole 2 pi and divided by that pi fourths, how many pi fourths do we have in there, right? So you'd do this. 8. We have 8 pi fourths sections, and that should be pretty intuitive to you guys, right? That we have 8 of these sections in here. That looks more like 6 when I do that. But we have 8 of these pi fourths sections in there, so we only want 1/8 of the entire circumference. Hopefully that makes sense to you. There's also another method that you could use. You can treat it more like cross multiplication. If you do pi fourths over x equals 2 pi over 24 pi, you can also do this and do the cross multiplication, because then it's 2 pi x equals 24 pi squared over 4. And then to get x alone, you got to move this over by dividing. So x ends up equaling 24 pi squared over 8 pi. One of the pi's cancels, and then 24 over 8 is 3. That's still 3 pi. So if cross multiplication method makes more sense to you, that's fine. You're doing the exact same thing. Okay. So we'll go ahead and switch to the next problem. This time it's going to be in degrees, but it really doesn't matter. Remember that circumference is 2 pi r. So 2 times our radius of 5 times by pi is going to be the circumference of this entire circle. So if we have 220 degrees that we start with, we're going to multiply it, and we're going to use a conversion again, but this time we aren't in radians, we're in degrees. So we actually want to use the degrees, and we want the degrees of the circle on the bottom. The reason we want it on the bottom is so that these degrees will cancel. Okay, and so this is the entire circle, and then this value is the entire circle, so we put 10 pi there. Okay, and then we put this in our calculator because nobody wants to do that by hand. So we do 220, we times it by 10, we divide it by 360, and we get that this is 55 over 9 pi units is the arc length for this one. Okay. Okay, so now we're going to switch over to talking about area. So remember that the area of a circle in general is given by pi r squared. So if we have this circle here, and we know that this entire area, all of the shaded area, is pi times 8 squared. Well, that's going to be 64 pi, right? But now we don't want the entire circle. We just want this little pi 6 angle of it, but we do want the area of the entire sector. Okay, the sector again is this piece. And we want the area of that sector. Now, this is not a triangle, right? If it were a triangle, it would be easy, right? We'd just be like, there you go, find the area of the triangle. But it's not. It's more like a cone shape. It has this arc over here, right? And so how we do this is we say, okay, we want just this portion of the entire thing. So how can we get just that portion? So here's what we do. We take that pi 6 measurement of our angle. We do basically the same thing that we were doing. That's in radians. So we need a radian on the bottom to cancel that out. And we know that an entire circle is 2 pi radians. We also know that the area of this circle in particular, the entire circle, is 64 pi. So our radians are going to cancel. One of our pi's cancels, and we end up with 64 pi over 6. Oop, not 6, sorry, 6 times 2, so 12. And of course, 64 over 12 does not divide evenly, so we need to just reduce it. And let's see, I think 4 goes into both of those, so 4 times 16 over 3. So this is going to be 16 pi thirds is the area of just that pink sectors section. Okay. And then we can do the same thing for this one. So 1 degree is just a teeny tiny amount of this circle, but that's a huge circle if it has a radius of 117, right? So we're going to do the same thing. We start with degrees this time, though. Remember, the area of this one's going to be 117 squared times pi. We're going to times by, we need degrees on the bottom now, so we use the entire degrees of a circle. And we want it, on the top, we want this 117 squared times pi. Which, of course, this 1 degree thing really doesn't change the numbers at all. It really just cancels out our degree for us. So then we just have to do 117 squared divided by 360, which reduces to 1521 pi over 40. That is the area of just that 1 degree little sector. So if we've got the big circle, this is just like this little teeny tiny part of it. The whole circle is much bigger. Okay. All right, so now we have to actually be able to use those in story problems. Also, if you don't like that I'm leaving pi in both of these, all you have to do is take this number and multiply by pi to get a better estimate of area, if that helps you. Okay, you're welcome to do that. So on this one, the orbit of Mercury around the sun is a perfect circle. Mercury is approximately 36 million miles from the sun. What this is doing is it's telling you the radius, okay? It's saying that the radius is 36 million miles, okay? And when it says it completes 0.0114 of its total revolutions, that's telling you we don't want the entire orbit's length. We just want this little bit, this little 1 day part of it, okay? and we want to know the measure from here to here, like how much is Mercury itself actually moving from here to here along this arc. So we have the 0.0114 revolutions, and we need to get rid of our revolutions. So one revolution would be how much? Well, one revolution would be from here all the way back around. And of course, that's just circumference, which is 2 pi r, or d times pi, right? So 2 times 36 times pi, right? So the entire circumference is going to be 72 pi. Entire orbit, entire circumference of that orbit, okay? So then we have that our revolutions are going to cancel, and we are left with 72 times by 0.0114, which is 0.8208 pi. And then we need to actually do this one because it doesn't want to know about pi miles. It wants to know about million miles, right? So we're going to go ahead and multiply that one in. So we're going to times it by pi. And this equals approximately we'll say 2.6 million miles, give or take. Okay. Now it also wants us to give it in radians. That's what this part B is. Okay. You have some choices here. You could just turn some things into radians from the get-go and realize that the entire circumference of a circle in radians is just 2 pi. Okay. So you could do it this way. You could do 0.0114 revolutions times by 2 pi radians over 1 revolution, and say, well, then that's going to be 0.0228 pi, and then actually multiply that in. And that is one way to do it. You also could take this and divide it by 36, because to get from here to here, 72 to get down to 2 would be dividing by 36. Okay, so you can do that. You can take that 2.6 million miles and divide it by 36. Either way, it really doesn't matter what you get. But if you do the divided by 36, then you have to multiply the pi back in, which kind of complicates things a little bit. So I'm just going to go ahead and do it this way, and I'm just going to leave it just like this. Okay, so you would divide by 36 and then multiply by pi. So this is what we get, is 0.0228 pi radians. All right. I am going to do this one. The others I am not going to do on the video. I think you guys can look at the notes and handle it. It's really just conversions over and over again, and I think that you guys are going to pick up on this pretty quickly. Okay, so we start with the information that the bicycle has wheels 28 inches in diameter, and that the wheels are rotating at 180 revolutions per minute, and we need to get it into miles per hour. So we need to go from inches to miles, and we want to go from revolutions to miles also. We also need to get minutes to hours. Okay, so we have a lot of conversions that we're going to have to do here. So I'm going to go ahead and start with the 180 revolutions per 1 minute. Okay, and I'm trying to get from revolutions into miles eventually. So I'm going to use what I know. I know that 1 revolution is going to be tied to this 28 inches in diameter, right? So if we have this bicycle tire that has a 28-inch diameter, then if we measure from here all the way around the circle, the circumference of that would be 28 pi, right? So 28 pi inches is per 1 revolution. 1 circumference around is 28 pi. Okay. And so that would cancel our revolutions. That's good. That's what we wanted. But now we also have to go from inches all the way to miles. So I want inches on the bottom so that this will cancel. Okay. And I know that there are 12 inches in 1 foot. But now I have feet, and I don't want that either. I want miles. So I'm going to put feet down here again. That's 5,280 feet are in 1 mile, which it did tell you in the problem if you didn't know. Okay. So now I've got myself down to miles per minute, but again, I don't want miles per minute, right? I want miles per hour. So I also need to adjust for that. So we're gonna put on we have minutes on the bottom, so actually to get rid of this one, I actually need it on the top. And of course there's 60 minutes per 1 hour. And then our minutes can cancel here. And then our units that we're gonna end up with are indeed miles per hour. And all we have to do is figure out the numbers now. So we can do 180 times 28 pi times 60 times 1 times 1. And we need to divide it by 12 times 5,280. And this can all be done in your calculator pretty easy. So 180 times by 28 times by 60 is 302,400. I have not multiplied pi in yet, and I'm going to hold off to do that for just a second. And then I'm going to do 12 times by 5,280, which is 63360. I'm going to try and reduce this first before I put it into pi. Just I think it makes it easier on your calculator's processing if you can do it that way. So that does reduce all the way down into 105 pi over 22. And then that times pi is, give or take, 14.994. So I'm going to go ahead and say that this bicycle is traveling right around 15 miles per hour. Okay. Again, I think that the others here should be pretty straightforward, but if you do have questions on example 5 or 6, let me know, and hopefully you guys are able to do your homework.